Okay, guys, we started 1.7 yesterday. So a couple of you that weren't here, you'll just need to catch up. But we're going to, pretty much everything we did yesterday is part of today, so you might learn quite a bit of it from what we're doing today. Don't forget the progress check we started on Friday is due midnight tomorrow. Okay, so if you were here on Friday, you at least started it. Maybe you only have 1 or 2 left to do, or maybe you just haven't hit submit yet. Okay, so just remember by midnight tomorrow, 11:45. When I say midnight, I mean 11:45. So don't wait till midnight, really. Okay, also tomorrow, so today we have 2 examples to do, and we'll start the homework. There were some people in one class that finished it, but first period hardly started it. It just depends how many interruptions and stuff we have usually. And we get out of here at 1:10 because of the shortened bell schedule, so just giving you a heads up that that's when the bell will ring. But we only have 2 examples, and I'm going to go over those, and I'm going to get to at least do 1, maybe 2 of the problems with you. And then tomorrow is a day 3 with no new notes, no new assignment. You will, I will need a few minutes of your time at the beginning of class, maybe 5 at the most, just to go over one last concept I couldn't fit in because of the changed bell schedule. But I won't be assigning any work from it. It's just something you need to know. You could see again. All right. So the rest of tomorrow can be working on either day's homework. So don't stress if you don't finish this. You can work on it in class tomorrow. You could get some one-on-one time with me. Can you explain horizontal asymptotes to me again? Or I don't understand how to factor this, or whatever it may be. You could use that time to finish the progress check that you started on Friday. You could use that time to start the quiz that opens tomorrow. So just as a reminder, plus I'm recording, so I want it on the recording. The 1617 quiz opens tomorrow. It's in AP Classroom. So tomorrow, 7 a.m. it opens. You will have it open until Tuesday the 26th. So it's open for about a week. And whenever I put a close date, it's always like 11:45. Okay, so you have that full day. There's no makeups on those. They're multiple choice. You can work together. You can use your notes. So tomorrow, maybe you have your laptop. So finish your homework and think, okay, I want to start the quiz, work on the quiz with somebody in the room or by myself or whatever. So just as a reminder, I encourage you to work together on online quizzes. I encourage you to use your notes. You're not cheating when you do that, okay? Just know you could work with someone from another class period too. There's 130 of you running around the school taking this class. I make the same quiz for everybody, but I think the questions are scrambled and maybe the answer choices. But you saw how the progress check worked. You can move between the questions. You can answer them and close down the program, and still it'll save your answers, okay? Just don't hit submit until you're ready to have it graded, okay? And then just like the progress check, once it closes, you'll be able to see what you got wrong and what the right answer was, so you can kind of learn from that, okay? Any questions for me about any of that? Okay, so as a reminder, we learned, one of the things we learned yesterday about was horizontal asymptotes. And we learned that we get our horizontal asymptote from the degree of the numerator and the degree of the denominator. So degree being the biggest exponent. In the numerator here it was 0 because there was no x, right? So x to the 0. And the denominator it was 2. So whenever the numerator's degree is less than the denominator, you'll have a horizontal asymptote of y equals 0. So a horizontal line at y equals 0. If the exponents are the same, 1 and 1, we then have to look at the a and the b value, which are the coefficients. So 3 and 1, 3 over 1 equals 3. So we have a horizontal asymptote at y equals 3. And then we had our third option when the numerator's degree is larger than the denominator's degree, like 2 and 1. It's like a line, and lines have no asymptotes, and we don't have an asymptote. We have none. Now we're going to take that idea one step further to something called a slant or oblique asymptote. You have a slant or oblique asymptote when the degree of the numerator is 1 higher than the degree of the denominator. That's it, 1. 1 single degree higher. So in this case, if I asked you what's the HA, you'd say none, because it does not have a horizontal asymptote. But then I'd say you would be able to go a step further and say, oh, but it does have a slant asymptote, okay? So it is a difference of 1 only, and it has to be bigger on top than the bottom. So if you had a 100 on top and a 99 on the bottom, that's good, okay? If you had a 5 on top and a 4 on the bottom, that's good. You can have a slant asymptote. But if you had a 5 on top and a 2 on the bottom, that would not have a slant asymptote either. You would have neither one, okay? Same as if you have 2 on top and 3 on the bottom. That's a difference of 1, but in the wrong direction. So your homework problems are 17 through 20. This part of the homework is 17 through 20. And there's 4 of them there, and 2 of them have no slant asymptote. Don't let them trick you. Okay, it says find the slant asymptote. Well, you're going to have ones that don't meet this criteria. So you'll say no slant asymptote. You don't even do the work. Not that the work is hard. We're going to review, hopefully it's a review for you guys. I found throughout the day with the other classes it was, review synthetic division. And that's how we find our slant asymptote. So here's some math language for you. Here is a quotient of 2 polynomials known as a rational function. The numerator is considered your dividend, and the denominator is called the divisor, okay? So dividend, divisor. And what you do to do synthetic division is we find the 0 of our divisor. Think about that. Finding a 0 means set the factor equal to 0 and solve. I don't think anybody needs to show the work for this. I'll do it one time. But the 0 of that denominator would be -5, okay? It's not an x-intercept because it's in the denominator, but it's just using that terminology. So we start with -5, and we do this little backwards, like looking L. And then we grab the coefficients of the dividend, the numerator, which coefficients are the numbers, right? So the number in front of the x squared is 1. The number in front of the x is -6, and the constant is 7. Okay, then what we do is we bring down the first term, whatever it is. It could be a 1, most of the time it's a 1, but if it's a 2, don't be alarmed. 2 is fine. This would just be a 2 right here, okay? Just bring down the first term, and then we do this. This should be quick, easy. There's not a lot of symbols to write. We multiply on the outside, so we do -5 times 1, and that gives us -5. And I put that in the first available spot. So I multiplied on the outside here. -5 times 1 is -5, and it went there. And then you add going down. So -6 plus -5 is -11. Then we start over. -11 times -5 is +55. Here's a spot for it. And then add going down. And now we're ready to write our answer. So here's how we get our answer. Our dividend was x to the second, right? That was x to the second. Whenever we write our answer, our quotient, which is the quotient is our answer. We always subtract 1 from our power. So this is x to the second, so this would be 1x to the first. We don't write a 1 in front of an x. We don't write an exponent of 1. That just becomes x. This would be your constant, and this is your remainder of 62. This is just division, but you never use your remainder for slant asymptotes. So your slant asymptote is just x minus 11. That's a line with a slope of 1/1 and a y-intercept of -11. That's why they call it a slant asymptote. It's a line that has a slant or tilt to it because it has a slope. The other 2 were called vertical asymptotes, which we'll graph in a second, and horizontal asymptotes, which we'll graph in a second. All 3 of them are lines. This one's just slanted because it has a slope, which tilts your line. Okay, let's just do another one. Let's do, I had one in my notes. Grab it. Let's do, just to practice, we'll do it kind of fast, because I don't think you guys are going to have it. Is it coming back to you, this synthetic division? I know if you had that one teacher, you did this a lot. She saw that I was doing a synthetic division today. She's like, my students better not ask any questions. No, she didn't say it like that, but you know what I mean. Okay, so our divisor is x minus 2. Find the 0 of it. So set x minus 2 equal to 0 and solve. I get positive 2. Backwards look an L and grab all the coefficients. The number in front of the x to the second would be 1. Then there's a -5. Then there's a 4. Doesn't have to be a lot of space. Don't make it lots of work. and we bring down the first term, and we always multiply on the outside. So the 2 times the 1 goes in that first available spot. Add going down. -5 plus 2 is -3. -3 times 2 is -6. Add going down. So somebody asked in another class, do I even have to finish the problem if I don't need that number? And the truth is you don't for this. The only thing I would warn about that is later on we will be using synthetic division for other types of problems. It's a kind of a handy tool with stuff. And you will need that. So you don't want to have like that muscle memory or whatever where you always cross that out, because then you might think that you're doing it later. So you just make sure you know that you don't always cross it out, just for slant asymptote. Okay, so this was x to the second. We always go down 1. So our slant asymptote would be 1x to the first, which is just x, minus 3. Remainder of -2, but we don't care. So this is a line, x minus 3. Y equals x minus 3. I just wrote it like that. Okay? So that's 4 problems of your homework. Question on those? Yes. I wouldn't go when I'm about to do this one, for real. This is putting everything together. This is a lot. But if it's an emergency, then go. But I don't really like using my class every day to come back and pass them. Okay, so example 4 we started yesterday. So all of the homework 1 through 8 yesterday was problems that looked like this, and all you were told to do was factor and find the domain. So we factored, found the domain. But now we're going to take it a step further, okay? So we're going to pull out a whole bunch of information out of this and use it to sketch a graph. And this will be the other part of your homework, which is 9 through 12, okay? So 9 through 12 of your homework will be these problems. And I'll be able to do at least 1, maybe 2 with you. So we start with the given rational function. We factored it. We decided who the problem children were, 0 and -2, right? Anything that makes our denominator a 0 is bad. So these are the problems, okay? And we pretty much stopped there. We put it in the domain, but we stopped there. Well, we're going to take it a step further. I'm going to go to the factored form of this guy. Let's rewrite it down here. And as we said, x can't be 0 and x can't be -2 because that would make our denominator 0. We don't care about the numerator. The numerator can be anything it wants, right? But the denominator is where we have some restrictions. What we're going to do now is assign these guys a job, because as I told you guys yesterday, algebraically, we showed this is what x can't be, but what does that look like on a picture, on a graph? We have to somehow show that these guys are not part of the domain. They are excluded. So they have to be excluded off the graph in a way. And I kind of mentioned it yesterday that the way that they're excluded is they are assigned a job of either a hole or a vertical asymptote. So a vertical asymptote is simply an imaginary vertical line that the graph can get near, but it can't touch. And a hole is simply an open circle. It's an ordered pair. It's just like on the number line, we'd have an open circle or a closed-in circle. It's the same idea. It's just called a hole. And how we tell the difference is this. Very simple. If the factor that you came from cancels, like those x's cancels, you are now a hole. We have a hole at x equals 0. Now I'm going to come back to the hole in a second. If you're left over, you didn't get canceled, you are a vertical asymptote. So each of them got assigned a job on the graph. Every problem number has to either be a hole or a VA. You could have 2 holes, you could have 2 VAs, you could have 1 of each. Okay, so there are times when you would say no hole, maybe nothing canceled. You have 2 vertical asymptotes, or both of them canceled. So you have 2 holes and no vertical asymptotes. So don't get hung up on that. Now, the VA is a vertical line. The hole is a point. So we need to take the hole a bit further. We need to find f of 0. We need to figure out what y is when x is 0 so we can write this as an ordered pair. Because we're going to have to graph it. 0 what? Where's the hole? We need the y value. So here's what we do. After we've canceled out those x's, I'm just going to rewrite the most simplified form of this rational expression. So it's the third version, really, that we're working with. We started with the original given one way up at the top. Then we factored it. That would be like version 2. And then we crossed out the x's, and that's what's left. Okay? This is going to be our friend for the rest of the problem because it's going to be the easiest place to plug into. Okay? Like right now. I'm going to plug 0 in to the numerator where I see an x, denominator where I see an x, and simplify it. When x is 0, what is y? So I'm going to plug in a 0 everywhere I see. I'm finding f of 0 basically here. So I get -3 on top, 6 on the bottom. Always simplify your fractions. Okay? So, problem numbers, assign them a job. If you cancel, you're a whole. If you don't, you're a VA. With the whole, you have to go a little bit further to plug in the 0 into the simplified version or whatever the number is, and then get the y. Okay? We also learned about HA. Let's find the HA. You could really use any version of this problem. The original, first one we changed, the second one, any of them. I think it's easiest to look at this one to find the HA because there's no parentheses, but I'll show you that it doesn't matter. So remember, when the exponents are the same, we then look at the leading coefficients. So this would be y equals 1/3. Y equals 1/3. Notice Bax and Hay. Remember that because I'm telling you it's a mistake students make all the time. And a great multiple choice question would be the HA being x equals 1/3 is one of the choices, right? It would be easy to see the 1/3 and grab it. But remember, horizontal lines are y's and vertical lines are x's, okay? But back to, if I had just used my simplified version, no matter what, if I could distribute the 3 if I wanted to, but this is a 1 and this is a 1, right? When they're the same, you look at the leading coefficient, so it's 1/3 here as well. Okay, so whether you use this version or this one, you would always get the same HA. Okay? There's 2 more things that we are familiar with that we could identify possibly, and that's the intercepts. So when x is 0, we get the y-intercept, and y is 0, we get the x-intercept. So, but there's a really shortened way to find x-intercepts now. Back when I teach this in Algebra 2, I don't tell them this. They actually do a lot more work. It's not very fun for them, and maybe that's how you learned it. But x-intercepts are really just any x's that are left in your numerator that didn't get canceled. So if I just gave you this polynomial, pretend there was no denominator. You would have said, oh, I have an x-intercept at 0 and at 3. If I set each of these equal to 0 and solve. Those are both x-intercepts. Well, it got more complicated with this denominator. So this 0 of x equals 0 that we canceled, that was here and here, is on the x-axis, right? 0, or it has x as its x-intercept. It's not an x-intercept. I keep saying that wrong. Forget that I was saying that. So this 0 here, it was already given a job. It's already got a job, so we've already assigned it. So we don't use it. It's not part of it. That's why I said this is our friend. But we have x minus 3 left in the numerator, so we would have an x-intercept at 3, 0. Okay? If there were several x's still in the numerator, we'd have more x-intercepts. You can have more than one, and you're going to see the one we do in the homework together doesn't even have one at all. So any x's left in the numerator is an x-intercept. There's so much going on in these problems, right? There's a lot. That's why these are nobody's favorites, okay? That's why we're going to practice, and we're going to practice more tomorrow if you need more time, okay? And I'll be able to help you. Okay, stay with me. Last one. Y-intercept, that's when x is 0. So really, all you have to do is go back up here and plug in a 0 here into our friend. But look, this should catch your eye right here. We already have our y-intercept. It's a whole. So we don't have another one. We have something on the y-axis, but it's already assigned a job, so we can't use it for a y-intercept too. We're not going to color in a hole that's not part of our graph. Okay? Now, when we sketch this, guys, I mean sketch. Don't you dare pull out a ruler or anything. This is supposed to be rough, okay? No perfectionism going on in here. We're going to start with the asymptotes. Okay, so put your asymptotes on there. So at x equals -2, I'm going to just make like a dotted line. That is a place on the graph I cannot touch or cross. And then y equals 1/3. That's a horizontal line, so if that's 1, I'll call 1/3 roughly right here, right? Doesn't have to be perfect. So I did my VA, I did my HA. I'll do my whole next. Left or right, 0, down, -1/2. So if this is -1, I'd be somewhere like there. Open circle, that's a whole. This is an open circle. It's excluding that point. And I have one more piece of information, and that's the x-intercept. 1, 2, 3, 0. That's everything I have, and I'm going to make my graph almost entirely right now with that information. Rational functions are like curves. They're called branches, but they're just curvy graphs. They are not perfect. I like to say that the arrows on the ends, they'll always have arrows on the ends, are like hands that are reaching out towards the asymptotes. They reach out closer and closer and closer. They won't touch them, but they'll get as close as possible. Is this exact? Heck no. But I'm not going to sit here and make a huge, long XY chart to get all these weird decimals and try and sketch it. This is good enough for this part of the graph. Now understand there's a second branch. It could be in one of two places. It could be right next door in this, like, look at my purple lines, my dotted lines, guys. Think of those as new quadrants. Ignore my red original XY axis. Think of this purple, this corner up here in the purple lines. That's like quadrant 1. Up here is like quadrant 2. Here's quadrant 3. And where our current curve is, like this quadrant 4, it just shifted, okay? You can either have one next door in this quadrant right here, quadrant 3, or diagonal. Either way, you're going to have a branch to the left of your vertical asymptote. So what you have to do when this happens, when you don't know where it is you make a baby, simple, don't overthink, simple XY chart and pick one number to the left of our asymptote. And let's make it easy and just pick the next number. So if this says x is -2, we'll pick -3. And we're going to get 1 point, obviously. We're going to get 1 point, an x and a y. If it's above this purple line, we know where the curve's going to be. If it's below this purple dotted line, it'll be in this quadrant. That's all we need to know, and we'll just sketch a curve. So I'm now plugging -3 into my simplified version. I get -6 on top. I get -3 on the bottom. And I get a 2 as my final answer. So now I know where my other branch is. Left 3, up 2. And that's good enough. That's good enough. You could pick more numbers if you wanted to, but I wouldn't make you do it. I mean, that's a horrible looking graph, but it's good enough. Okay? If you had chosen -4, same thing. You didn't have to use -3. Anything to the left of the asymptote, but my advice is just pick the one directly to the left because that will match my P. So wherever your vertical asymptote is, pick one to the left. Okay? All right, I'm going to do another one with you from the beginning all the way through, right in your homework, okay? Not another example to take your time. I'll go right to homework with you. Question before I get there, though? Yes, Ty? Right here. Remember my two numbers that x can't be? X can't be 0. If I set 3x equal to 0 and solve it, I get 0. And x can't be -2. Those are my two bad numbers. So when I canceled these x's, those x's gave me that 0 value. That made it a whole. We're going to do another one right now. I think, because I know you missed yesterday, I think it'll make a connection for you right here. If not, tell me, and I'll talk to you again about it. Okay? Let me try it from the very beginning with you. So your homework is a 20, I think you already know, 9 through 12, that's the ones we just did, and 17 through 20, which is the slant asymptote ones, okay? So 9 through 12 are the harder ones, but really important. It's tying together almost everything we've learned. And there's lots of parts to them. They're not fun. We just are going to deal with it, okay? Nobody says, let's do more of those. Those are really fun. Okay, we have to ignore the directions. We're doing exactly what we just did. We're going to factor it. We're going to find all the stuff, we're going to sketch the graph, okay? And it all starts with factoring. If you can factor the numerator, you do. If you can factor the new denominator, you do. And I can do the denominator, right? That's a chart problem. If you need to make the chart, by all means. I don't need to. I'm an expert. Just don't need to brag, but I am. But just know we have to know how to factor, okay? And that's the factored answer. So looking at that, Ty, I'm looking at that denominator. Anything that makes my denominator a 0 is bad. So I know x can't be -3, and x can't be what else, guys? -2, right? I'm just looking at the denominator. Now, what type of problem are these going to present to us on the graph? Their choices are a whole or a VA. So, since, watch, I cancel the x plus 2's, that means it's a whole. It's just by the fact that we cancel it, it makes it a whole. So we will have the whole at x equals -2. That's this guy, and I'll come back to it and finish it. Whatever's left in the denominator, if anything's left, becomes a vertical asymptote. So I am giving both of them a job according to what happened with their relationship with the numerator. Don't forget, we need an ordered pair here, -2 something. So I'm going to rewrite this simplified. If there's nothing left on top, you would put a 1, okay, and the x plus 3 on the bottom. So after I simplified it, this is my most friendly version of this, right? It went from factored or standard form, factored form to simplified form. This is the one I'm going to be looking at the most. Could I use this one for a lot of it? Yeah, but it's more work. Could I use this one for a lot of it? No, honestly, you couldn't because you would get some zeros, but don't worry about that. Just use this one. Okay, so I'm going to plug in a -2 where I see an x. So when x is -2, y is what? 1, yeah. Because -2 plus 3 is 1, and 1 over 1 is 1. All right, so we now know where our open circle is going to be. We've got our vertical asymptote. We can easily do our HA, another concept from yesterday. When our degree on top is smaller than our degree on the bottom, right? 1 is less than 2. We have a horizontal asymptote of y equals 0. Remember, we talked about just memorization there. X-intercepts come from any x's left in your numerator. Remember the last problem? We had an x minus 3 left on top. We got a 0 from that of 3. What's left on top of this one? There's no x's, so we have no x-intercept on this graph. That's fine. That can happen. And y-intercept is whenever x is 0. Again, I can just use this nice friendly friendly version. Plug a 0 into the denominator, and I get 1/3. Okay, that's all I can do right now. I might have to do an XY chart and find up 1 point, but I don't know where that is until I see the picture. It's so much easier to do looking at the graph, so I'll hold off. And sometimes you get lucky, and maybe your x-intercept or y-intercept is in one of the other quadrants, and like your whole is another, and you could already see where the two are. So sometimes you don't have to do an XY chart. That happens on number 12, by the way. Remember that. Okay, so I'm going to put my vertical asymptote on at -3. X is -3. Y is 0. Guys, that is just on the x-axis. That should now make sense why we don't have an x-intercept. You can't put a point on an asymptote. That goes against the rules. You can't touch your asymptote or anybody else's asymptote. It's rude. Don't go around touching asymptotes. Elizabeth, smile. Okay, we have a whole at -2, 1. So to the left 2, up 1. Whole is just an open circle. Don't overthink it. We don't have an x-intercept, and we have a y-intercept at 0, 1/3. So 0, and then, I don't know, right there. Call it right there. So I see where my first curve is going to be, my first branch. It's in this little corner here. So I need a branch on either side of my vertical asymptote. So I need a little baby XY chart. Don't cry about it. It's okay. We need a point to the left. So if our vertical asymptote is at x equals -3, maybe use -4. I always pick the next number, so if you want to match my key, that's probably the best thing to do. All right, and I'm just plugging it in. 1 over -4 plus 3. -4 plus 3 is -1. So I have 1 over -1, which is -1. Now I know where my other curvy is. It is left 4, down 1. I can see it's in this quadrant. That's enough information for me to graph my other curve. So the two we have done are diagonal. Look, all 4 of them end up being diagonal, just so you know, but they could be side by side too. In case anybody still needs help with factoring these long factorings, I'm just going to go ahead and do it. If you feel fine to go ahead and work, that's fine. But I did one of these with you yesterday also. I'm trying to give you guys as much help with the factoring now because you really need to know how to do this. This is a quadratic trinomial. We factor it using a chart. What makes it different is the 2 in front. So if you need to make the chart, just remember we are including the 2 with the times 6. So it's 2 times 6 is 12, and the b value is 7. So it's 12 and 7, 3 and 4 are our numbers. When all of the signs are positive in our polynomial, all the signs here will be positive. We like those. So if the 2 weren't there, we would write x plus 3, x plus 4, right? But because the 2 is there, it's really only got a little extra work. Bring down the outside 2, split the middle. What do we split the middle into? These two numbers. Doesn't matter which one goes first. Put an x on both of them. They should equal the number that you're splitting above. The rest of this should be cake. 2 and 2. It's the factoring when you have grouping. So you do 2 and 2, GCFs, parentheses should be identical twins, that whole thing. So my numerator factors out to 2x plus 3, x plus 2. And if you want to go ahead and put your denominator right here, that's a chart problem too, but not the longer one. Two numbers that multiply to get -6, add to get -1 are -3 and +2. So here's the factored version of the given. Now you can start canceling and going through all the steps. And I'll put the key up after I know you guys have finished writing this. So come tomorrow prepared to either finish this, ask for help on any of the days, work on the quiz alone with a friend, bring your laptop if you want to. Make up any homework checks at the end of the period.